Now this is a bank curve problem. So what bank curves do is that they arrange something at an angle so that the car will stay traveling without the help of friction. Now sometimes friction is there, but not all the time. So for these particular problems, all we have to worry about is the angle. And when it's of a certain size, everything's okay. So we want to figure out what the angle needed for an expressway off-ramp curve so that it will keep cars on it without friction. So the radius of this curve is going to be 50 meters. And the velocity that we're going to be working with is going to be 50 kilometers per hour, which converts to 14 meters per second. And we want to figure out what angle do we need to have the ramp banked so that the car will stay on it. No friction is needed. So what we have is the equation. We went through this in class when we figure out what is equal to what and what parts of the formula are equal. We end up with velocity is equal to the square root of RG tan theta. That's what we end up with. That's the equation you need to know. So if we want to figure out what the angle is, we're going to have to rearrange this equation. So the first thing we have to do is square both sides. We get velocity squared is equal to RG tan theta. Then the next thing we have to do is divide both sides by RG. So when we divide both sides by RG, we're going to end up getting V squared over RG, and that's going to be equal to the tangent of theta. And then we want to get theta by itself, we have to do the inverse tangent of the angle. So we're going to end up inverse tangenting both sides. So we're going to end up with a final equation to find the angle of tan inverse V squared over RG, and that's going to give us our theta. So we know all that information in this problem. We know the velocity that we're looking at and working with is 14, so we do 14 squared. The radius is 50, and the value for gravity is 10. So we have 14 squared divided by 50 times 10. So tangent inverse of all that is going to give us tan inverse of 0.392, and the tan inverse of 0.392 is going to give you a theta of 21.4 degrees. So this road can only be banked at 21.4 degrees. Now what you don't need to know is how to get to this point. What you do need is this equation here, V squared is equal to RG tan theta. And you also need to know this final one. So if you want to rearrange, I'll give you a list of which equations you have. So the couple options you have, velocity is equal to the square root of RG tan theta. Okay. R is going to be equal to velocity squared divided by G tan theta. And G is going to be equal to velocity squared divided by R tan theta. There isn't really a situation where you need that. And the last one, theta, is going to equal the tan inverse of V squared divided by RG. So these are your options for a bank curve problem. These are the only 4 equations that you could possibly have and need to solve for.